Alright, today's lesson is going to be on real numbers and operations. So you're going to open your notes to the first blank page and you're going to title it Real Numbers and Operations. After you've written real numbers and operations, go ahead and draw a number line like so. Hopefully you draw it a little straighter than mine. We'll start off with 0 in the middle. We'll go up to 1, 2, 3. So we have 1, 2, 3 over here, -1, -2, and -3. This number line represents all numbers in any direction because you could go this way into infinity and you could also go this way into infinity. Either way. And all of these numbers are called real numbers. You're going to write real numbers right below the number line. Real numbers. Real numbers to the right of the number line are positive. So we have positive to the right of the number line. And to the left of the number line, of course, are negative numbers. So on your notes, make a note to yourself that draw a line to the right, and that is the positive numbers, and draw a line to the left, and that'll be the negative numbers. So on the one hand, we have rational numbers. Rational numbers are any number that can be rationed. Like we can think of a number like 1 or 2, or even a number like -2.5, which is between -2 and -3. However, there are some numbers that are irrational. In other words, they don't just have a simple number value. So these are known as irrational. And you should write both these down in your notes. Rational numbers are numbers that are easy to see, like 1, 2, 2.5, whereas there are some numbers that are irrational. For instance, in the rational side up here, we have numbers like the square root of 4. We know that the square root of 4 is 2 times 2. However, what about the square root of 3? There is no number, two numbers that you can multiply together to make exactly the square root of 3, so this is irrational. Or for instance, the symbol pi. The symbol pi, sometimes we call it 3.14, but the numbers actually keep going on forever and ever and ever, and the numbers, there is no sort of pattern to pi. It just keeps going on forever with no pattern. And so numbers like this are irrational because it cannot. Irrational numbers, and you should write this down, irrational numbers cannot be expressed as a ratio of integers. For instance, going back to rational numbers, a ratio is any two numbers like this. For instance, a ratio is let's say this is a ratio. We have 4 over 2. We're comparing these two numbers. And when you do 4, you know that this sign right here means divided by. 4 divided by 2 is 2. Therefore, we know that 2 is a rational number because we can take two integers like 4 and 2 and we can express it as a ratio of integers. We have a ratio of integers here and we divide them, we know it's rational. However, if you take, for instance, the square root of 8, there are no two numbers that we can make something times something to equal, and so we know that this one, on the other hand, is irrational. And you should write all this down in your notes so that you know the difference. The rational numbers are numbers that are easy, that we can just deal with on an everyday basis, whereas irrational numbers cannot be expressed as some sort of combination of two integers. Now we are going to look at 4 examples. So I want you to write down examples in your notes below what you've just done, and we're going to look at 4 different examples. The first example is 8, and you should write this down, 8.97, 497, 7, 4. Dot, dot, dot. This ellipses means that these numbers just keep going on forever, but they keep following this pattern, 974, 9774. So we'll put numerals repeat. So if these numbers keep repeating, 974, 9774, 974, 9774, if the numerals repeat, this means that this answer is rational. It's rational because the numerals repeat. Number 2, let's look at another example. Let's say we have a number like 3.1, 2, 1, 1, 1, 2, 1, 1, 1, 2, ... This means that the numbers keep going on forever. Let's say this time, however, that the numerals or the numbers do not repeat. If this is the case, then we have to say that this example is irrational. It's irrational because there are no repeating decimals. Unlike up here where the numerals repeated, these numerals do not repeat, so it's irrational. Another example. Let's say, for instance, we have something like 4.325, and then the numerals end. So we have 4.325. Now they don't repeat here, but the numerals just end. It doesn't keep going on forever and ever and ever. If the numerals end, in other words, the decimals don't keep going on forever, then the answer is rational. And it is rational because the numerals end. And one final example, let's look at the square root of 17. The square root of 17 is not a perfect square. And because it is not a perfect square, there is no one answer that will help us figure out what the square root of 17 is. There's just going to be some sort of two numbers that are going on forever. And so since it is not a perfect square, this one is irrational. Okay? And that is your sort of introduction to when you know things are rational, is if the numerals repeat, then it's rational, or if the numerals end, then it's rational. But if it's not a perfect square or the numerals do not repeat, then we always have to say that the numbers are irrational. The next thing we need to review, and this should be a review from Algebra 1, is you have 0, and then it goes 1, 2, 3, 4, -1, -2, -3, -4. Well, if we have these answers here, then we have 0. And let's say we have this answer right here, 3. The distance from 0 to 3 is the absolute value. So write absolute value. This is the next part of our notes. Absolute value is the distance to 0. So for instance, the way you write it is you make two little lines like this, and so we know the absolute value of 3 is 3. Where it gets complicated, however, is let's say we're at -4. So we have from the distance from 0 to -4. If we were to measure from 0 to -4, we can't have a negative distance, and so the answer is 4. So for instance, -4, the absolute value of -4 is 4. Okay? So it's always the distance to 0. And there is something known as the shower rule, which I will write for you right here. And that is that it's kind of like the absolute value signs, the numbers always come out clean or positive, or so like for instance, when you come out of the shower, you're always clean. So for instance, if you had the absolute value of -6, you clean off the negative and the answer becomes +6. However, let's say you have a -6, but then on the outside of the absolute value you have a negative sign. This would be like taking a shower, getting all clean, and you come out with a +6, but then when you step out of the shower over here, there's a negative. It's like stepping into a puddle of mud. So the answer is still -6 in this case, because there's also a negative on the outside of the absolute value. So the only time you would get a negative number is if you have a negative on the outside of the absolute value. This is the rules for additions of real numbers. So this is just, we're going to talk about addition of real numbers. So let's do some examples here. Let's say we have, so this is the next thing of our notes, addition of real numbers. Let's say you have -5 plus -9, all right? Always, always, always think of the negative as a debt. meaning that you owe someone that kind of money. So for instance, this would mean that you owe someone $5, and then you're adding on $9 more of debt. So you already borrowed $5, and then you're adding on, that's what the addition sign means, you're adding on $9 more of debt. In this case, you would now owe the person negative $14. However, let's say you start off with a positive. Let's say you have positive 23, and you're adding a debt. So in this case, you start off positive in this one. So right here, we have $23, and then we borrow $11. So we have $23, and then we borrow $11. In order to pay the person back, we're going to have to take $11 from our $23 to pay them. So this becomes a subtraction problem. 23 minus 11, 3 minus 1 is 2, and 2 minus 1 is 1, so this becomes 12. So when you are adding a debt, it becomes a subtraction problem. Even though you're adding the negative, it's still a subtraction problem because this thing right here, this negative, is always a debt. And so basically you're adding $11 of debt to your 23. So 23 add $11 of debt, it comes out to a total of 12 because you have to pay this person back the $11. How about, however, let's say you have negative, let's say you owed someone 9.2 or $9.20, and you have $3.10. In this case, you still have to, it's still a subtraction problem because you owe someone $9.02. I mean $9. It's basically like 9.2 is the same thing as $9.20. And you get $3.10 from someone else. What are you going to do with this $3.10 if you owe someone money? I mean, if you do the right thing. What you're going to do is you're going to add it so that you can get some of your debt taken away. So it becomes a subtraction problem. So it's 9.2 and it becomes minus 3.1. Okay, 2 minus 1 is 1, and that's 9 minus 6 is, 9 minus 3 is 6. And so 6.1 is how much we owe now. And so the answer is negative because the negative, we have more of a debt than we do of our own money. So if you had $3.10 but you owed someone $9.20, you would still owe them right here $6.10 or 6.1 when the time was over. So what I want you to do now is pause the video and turn to page 6. On the next blank page, turn to page 6, and I want you to do G, H, I, J, K, and L on that page. So do G, H, I, J, K, and L on page 6, and that will be your first assignment for the class. The next thing we need to talk about is the subtraction of real numbers. So we're going to talk about subtraction of real numbers. When you subtract real numbers, for instance, let's say you have 5 minus 3. This means basically you have let's say you have $5 and you're spending 3. That's a fairly simple one too. However, let's say you have negative 3 and you're subtracting 2. So now what this means is, remember, the negative always means a debt. So you have a debt of 3, and then you're also taking on another debt of 2. So you have a debt of 3 and you're taking on 2 more debt. So you have a total of 5 debts, or $5. If it was dollars, you have $3 of debt, and then you're borrowing 2 more dollars of debt for a total of negative 5. So you have negative 5 debt. So if you're doing a negative something minus a negative, the answer is going to be an addition problem, 3 plus 2, but you're going to keep it negative because you owe 3 and then you borrow 2 more, so now you owe 5. However, and this is the one that always gets kids tricked, is like, let's say you have 3 minus negative 4. In this case, remember that the negative means a debt. Well, in this case, it means that you are if you have 2 negatives in a row, it's like saying you have a debt, but then you are taking away the debt. So you're taking away the debt. So it becomes 3 plus 4, which equals 7. So whenever you have 2 negatives right next to each other, it always becomes a positive problem, and it equals 7 in this case. So what I want you to do is pause the video, and on your notes, again, go to page 7, and I want you to try to do numbers 1 through 28. So you're going to do page 7 and do numbers 1 through 28 because you should be ready now to practice these problems, these 1.1 exercises.